US Standard Time comes from a group of atomic clocks running 24/7 at NIST. They are called hydrogen masers, but how do we know they are accurate? Meet NIST F4, a cesium fountain clock that serves as our nation's primary standard for the measurement of a second. Its measurements are used to calibrate the ticking rate of hydrogen maser clocks, just like how a tuning fork is used to tune musical instruments. Here's how it works. First, a gas of cesium atoms enters a vacuum chamber. Then, laser beams cool the atoms, slowing them down and grouping them into a cloud. Cesium atoms move between two energy states, higher energy states and lower energy states. Think of them as sides of a coin, heads and tails. At this point, all atoms are in their higher energy state, or heads. Then, the cloud of atoms is launched upward by the vertical laser cooling beams, toward the state selection cavity. As the atoms travel through this cavity, the state selection microwaves put the atoms that are in the higher energy clock state into the lower energy clock state, and the rest are driven away by a laser pulse. From now on, we only want to measure atoms in the two clock states. The now less dense ball of atoms continues its journey upward to another enclosed space called the Ramsey cavity, where it meets the main microwave field. The microwaves hit the cloud of atoms, and the atoms start oscillating between the upper and lower clock states, like a coin flipping between heads and tails continuously. The atoms leave the cavity, continue upward, and then fall while still flipping between heads and tails. The atoms interact with the microwaves a second time as they pass through the Ramsey cavity again, allowing the atom's ticking rate to be compared to the microwave frequency. The atoms then pass through two detection zones, where lasers check how many atoms are in the upper clock state and how many are in the lower clock state. If the microwaves are ticking at the right frequency, then half of the atoms will be detected in the upper clock state and half will be detected in the lower clock state. This reveals how close the microwave frequency is to the cesium resonant frequency, which is precisely 9,192,631,770 Hz. And how the world defines the second. If the atoms aren't 50-50, we tune the microwaves until they reach the resonance frequency. Once tuned, we can properly adjust the frequency of the hydrogen maser clocks to sync them with the ticking rate of NIST F4, like a metronome producing a steady beat to keep musicians in sync. The fountain calibration process is repeated periodically to make sure the masers stay accurate.